Hello, this is Parker Kim, and today I'm going to explain number 5, a possible video ID question. Before starting, I just want you guys to know that with this method, my own methods, you might not be able to get a full point for number 5 question. However, I think it is really valuable for math learner to share their own methods to extend their kind of vision or viewpoint to solve question. So I decided to choose my own method for this video assessment. Right, so let's get started. Number 5 is saying the graph shows a normal curve for the random variable x with mean and standard deviation. So we know that we don't know what is mean and we don't know what is standard deviation from the x distribution graph. However, we're given one information. It is known that when x is greater or equal to 12, probability is 0.1. And super luckily, number A is asking about us that if region A is when x equal to 12 or bigger than 12, what is the area of that corresponding x value? Obviously, number A is 1 point question. You should write down the answer quickly. You should not waste a lot of time for this question. We are given the probability of x is greater than or equal to 12 is 0.1, and we know that probability of the corresponding x value is equal to the area of the corresponding x value in the x distribution table. So we can just directly write a is equal to 0.1. However, for safety, it's good to, I recommend you guys to write this one. Probability of x and a corresponding value is equal to the area of the corresponding x value on the graph. Let's move on to number B. Okay, number B said, find the value of mean. Explain your method in full. Okay, so this is number 5 question, point 5 question. So we have to write our methods and solution in detail. So how I started my method is by writing all the given information. Standard deviation and mean is not known, is unknown for x distribution table. However, there's some clue. We do know it's the mean value and standard deviation of z distribution. So I was thinking that, oh, maybe I could do something by transferring this x value into corresponding z value. Maybe I can do something with that. This equation is basically what this equation is transferred to this equation, because we know that the probability of the area when x equal to 12 or smaller than 12, which is from here to all the way through here, is equal to 1, which is whole, minus 0.1, this shaded area. So we can just directly say, convert this equation to this, which is probability of x is smaller or equal to 12 is equal to 0.9. And then the reason why I converted in this form is that I expected somewhere between here and there, I have to use inverse normal. And we all know that in order to use inverse normal, the condition of x is smaller or equal to some value. Yeah, not be greater or equal. So that's why I converted in this form. So we are given 2 equations and 2 unknown variables. So I thought that maybe we could use system of equation in this situation to find out 2 values. So I started by z8 is equal to 8 minus u divided by standard deviation. So this z8 is the z value that corresponds with x8. So, and then I stated this very important statement that probability of z distribution and x distribution are equal as long as their x condition is same. right? And okay, so I stated this for safety, for method point maybe. And then from this equation, I thought like, for this equation, I was thinking, oh, what could I do more from this equation? And I realized that maybe I can find this value, Z8, because I know the standard deviation and mean value of Z distribution, which is always constant 0 and 1. And if I use inverse normal by using calculator, I can find the Z8 value. So this is different model as TI and Inspire, right? Previous model. So it has different weight. So push second, var, go to inverse normal, and we know that in Z distribution, when Z is equal or smaller than 8, the probability is also 0.1, same as X distribution. So we write down the area. And also we can use inverse normal because the condition is X equal to something or smaller to something. Okay, so we know mean value, standard deviation, paste. I got -1 to 8, blah blah blah. And then the reason I put this value, the reason why I put these dots there is to remind you guys that when you use calculator to solve looking for some value, you always have to keep all the decimal places and then round at the end of the calculation for the final value. Okay, so I directly equalize this value with this equation. -1.28 is equal to 8 minus mean divided by standard deviation. I multiply both sides by standard deviation and also divide both sides by -1.28 to isolate standard deviation to left side. And I just distributed this one into the brackets, so 8 divided by -1.28. And since in front of mean value, there's -1 as coefficient. So -1 divided by -1.28 is equal to 0.78. So it becomes coefficient of the mean value. And this is the one equation that I derived in order to get the mean value. And here is same. I just proceeded. I just continued with the same method to derive this equation. Alright, so we have two equations and two unknown values. What can we do? We equalize two equations, merging two equations to derive one equation and solve for one unknown value. So do some math, rearranging here, derive this equation and divide both sides by 1.56. I got mean equal to 10. So this mean is for X distribution, not Z distribution. So we should not be complicated with that. Right. Number C. Okay, let's move on to number C. Number C is asking that show that if standard deviation is 1.56 to an accuracy of 3 significant figures. Alright, so this is very simple question in my method because we already derived two equations and we can just use one of these equations because we already know this mean value, and if we plug this mean value to one of these equations, we directly get standard deviation. Very easy. So I just use this equation. You can use this equation too. Bring it down, put 10 in it, and then I made sure to use full significant digit. And then the reason why I wrote like this before I write the final question is that to show that I rounded correctly. Because the instruction is kind of emphasizing that show this value accurately in 3 significant figures. So maybe I kind of expected that rounding correctly is one of the criteria for method points in number C. So let's move on to number D. It's a very simple question. It says, Find what is the probability when x is smaller or equal to 11. Very simple. So it's basically asking what is the area from negative infinity to 11. What's this area? Now how we do that? Well, if you use calculator, it becomes very, very simple. Just one step. Just reminding you, this is different calculators. So you push second bar, go to normal CDF. So what does this normal CDF do is that it calculates the corresponding probability for normally distributed graph. You can't use this for any data, but if the data is normally distributed, you can use this function to calculate the probability in it. Okay, so lower boundary. Lower boundary is negative 10 to the power of 99. This is basically saying negative infinity. So just reminding you, lower boundary in math is usually when we talk about sign diagram or graph, it's always left side, the most left side. Okay, and then the upper boundary is 11. Maybe just figure it out. Standard deviation, which is standard deviation is 1.56, and the mean value is 10. Just push, get the answer 0.3924. There you go. And I round it to yield final answer of 0.739. Right, that's it. This might be a little bit off topic, however, it's really important thing that we should know about math and really closely related to the main goal of my video. So yeah, I think I should talk about this. So what's really interesting and fascinating about math, and especially IB math, is that there are thousands of solutions, ways, pathways to approach an answer. So for example, there's one answer. There's answer right here, and then there are lots of pathways to reach that answer. Some pathway takes a longer time than the other pathway, and some pathway takes very short time, and some pathway even don't gives us to the answer, takes us to the answer. Some pathway is very long, right? So this is one of the kind of adventures aspect of math, is that we as a student, we as a solver, we gotta find a way. We gotta choose the most effective way in a given time. So that's why IB exam or IB math is kind of we're playing game when we are solving questions. It's like that. So how we do that? How we find the math pathways? Through closely analyzing and reading the given information, known values, unknown values, looking at the graph, given information, we can find the most effective way to reach the answer. So that's really adventurous aspect of math. And what is more interesting is that maybe one student A, can only see this pathway. Maybe student B only has a vision to see this pathway. Student C can only see this pathway. Student 4 see this pathway. Student E can see only this pathway. However, what happens if all of these students, like we're doing in this video, all communicate together and share their method? Then student A, B, C, D, E can all together can manipulate and can use and know all of these pathways. So that's why math is such a valuable subject, I think, because it encourages us to cooperate for the better performance.